Hey guys, today we'll be going to this question in lesson 3.3. The example is Lewis lifts a 100 kilogram weight as shown. After point 3, he drops the weight so that it comes to stop after striking the ground. So this is the diagram given, and we have 4 situations and this table that we have to fill in with work gravity, work Lewis, and force Lewis in between each point, at point 3, and then back to in between 3 and 4. So the first box is work gravity, and to find work, we know that work equals force times displacement, and the force of gravity is equal to mass times gravity. So we find force of gravity, which is the mass of the weight, which is 100 kilograms, times 10, and that equals to 1,000. But work is force times displacement, so we have the force and the displacement in the diagram. From between 1 and 2, the weight moves up 1.5 meters. And since it's starting at the ground, the total displacement is 1.5 meters as well. So that's 1,500 joules. So work Lewis we can find by running out the energy equation for this situation. So we have E1 equals E2. We have GPE1 plus work Lewis equals GPE2 and KE2. GPE1 is 0 because it's on the floor, so we can just do work Lewis equals GPE2 plus KE2. GPE2 is mass times gravity times height, which is 1.5 like we said in the other box, plus kinetic energy, which is 1/2 mass times velocity. On the diagram it says V2 is 2 meters when it's at point 2, so you have 2 squared. And this would equal out to 1,700 joules. Force Lewis, we can do the work equation again. Work equals force times displacement. So we have 1,700 equals force times displacement, which is 1.5, and force would equal out to 3.3, and then this is continuing newtons. The second row, we're looking at the situation between point 2 and point 3. So at this point, velocity 2 is 2 meters. It's at 1.5 meters. At the top, velocity is 0, and the total height is 1.7 meters. So work gravity, we can pretty much do the same. So work equals force times displacement. Force gravity equals 100 times 10, and the total displacement is 1.7 minus 1.5, and that should equal to 200 joules. Just to note that both of these, the work of gravity is always going to be negative in this situation because the force of gravity is going in the opposite direction of displacement. So we know force of gravity is acting on the weight downwards, but the weight is moving upwards. So since they're opposite directions, work's going to be negative. So work Lewis, we can find it by using energy again. Energy 1 equals E2. So we have GPE1, which is GPE1 plus work Lewis, plus KE2. Or we'll call this 2 just to stay the same with the diagram. And then we have GPE3. because the weight's not moving at the top because the velocity is 0. So if GP2 is 100 times 10 times 1.5 plus work Lewis plus KE2 1/2 mass velocity squared equals GPE, which is 100 times 10 times 1.7. So we solve this out, we'll have work Lewis plus 1700 joules equals 1700 joules. And you subtract, you just find out force Lewis equals 0. And if you're wondering why it still moves even though he's not applying any force, it's just because there's kinetic energy and it's still moving, and it'll come to a stop right here. Force Lewis is just going to be 0 newtons because work is 0. And I'm just work equals force times displacement. Yeah, so work is 0, force has to be 0. Now we have work of gravity and Lewis and force at 0.3, so when he's holding the weight up. So at this point the weight's stationary because velocity is 0. So we have work of gravity is 0 joules. Since we're looking at it at 0.3, the weight's not being displaced at all. So if we use work equals force times displacement is going to be 0, and therefore it doesn't matter what the force is, it's just going to be 0 joules. Same with work Lewis. But even though it's not moving, even though work is 0, there's still going to be a force. So we know that the weight is staying at 0.3 at 0 meters per second. So we know that there has to be some force holding it up. And we know force gravity equals mass times gravity. And we know it's 100 times 10, and it's 1,000 newtons. The reason why this is the same as work Lewis is because Lewis is the normal force acting on the weight to hold it up. And then as it drops, 3 to 4 is when it drops to the floor from that height. So we know that work gravity is going to be force times displacement. And we know it's going to be 100 times, force is 100 times 10, force of gravity. And then we know displacement is going to be 1.7 because it's dropping all the way from the top, and height 3 was 1.7. So that's 1,700 newtons. And it's positive it's 1,700 joules. And this is positive this time because force is acting downwards and it's moving downwards. Work Lewis is 0 joules, and so is force because he's just letting go of the bar.